Okay, so first part of the assignment 1 demo. Demonstrate that all clients respond to changes made by one. So I'll boot up a server and a few clients and show the inter-process communication. Okay, so here we have 3 clients. I'll enter a command in one, and you can see that the others follow suit. So now the next stage is to use debug mode on one. So I'll start up a server, 2 clients normally, and a client in debug mode. Show the connect, finish connect, property change, write, read, process command, and tracing. So I'll let these all spin up first. Go into debug mode. So we can see in the main thread of one of our clients, we enter the initiate connection method, which calls connect on this socket channel. Then after it connects, the select thread now issues the finish connect function on the socket channel. So now the next step is to enter a command and see the property change method being called. So that should be this simulation. So we'll enter a command, and we can see that the AWT thread calls the property change function. Then the selector thread executes the write function right here. Then we want to execute command remotely, so we can see it call read. So we'll let this run its course. Then, we'll go to another simulation. We'll also we'll move this up 50. So we can see the selector thread now calls read. And then we want to see it call process command. So let's see. So inside the remote operations thread, seem to have skipped past it. Apologies. Let me run this one more time. So we call read here. And then the remote operations thread grabs an item out of the queue and processes the command. And you can see they've both moved up again. So the last part of this is to show the trace. So starting at the top, we can see a socket channel connect initiated, registered, and finished. Then we see a property change happening, which kicks off the write. Then we read that value echoed back from the server. This was the write from the first command, and now we're reading in a command from another client. And then process command is called on that received command. So our next step is to create an inconsistency here. So what I'm going to do is move all of these clients back up against the wall. So move everything -500. That way they're all up against the wall. And what I'm going to do is execute a move 50 forward in the debugged version and a move 50 backwards in the non-debugged version. So after this client sends its message out of moving 50 forward, I will halt it before it processes the command itself. And then I'll have these two move 50 forward and then execute a move 50 backwards. So they'll end up moving forward and backwards to their same position. I'll have this process read that 50 backwards over the network, and it'll try to move 50 backwards but not be able to. And then finally process its own 50 forwards. That way it will end up 50 units forward from this back line, while as these two simulations will still be at the back line. So move 50, go send out a non-atomic broadcast, and then halt before processing the command. Okay. But I do need to go to the selector and write. Okay. So now these two simulations have both moved 50 forward. And now I'll have them move 50 backwards. And I'll have this thread read that. And process that command. So that's been processed. So these have both moved, these two simulations have both moved 50 forward and backwards, back to the same position. This simulation, the debugged one, has moved 50 backwards, unable to move backwards, but has not yet executed this move 50 forward yet. So I'll have it execute that now. Oops. Finish that up. So now all three simulations have received both commands, but because this debugged command received them in a different order, these are all out of sync. Okay, so now I have to demonstrate atomic broadcasting, and this time I'll need the server in debug mode as well. So I'll close out of all of these. I'll instantiate a server in debug mode. Oops, I think I just made too many servers. So, server in debug mode. Go back, instantiate two normal clients, and client in debug mode. I seem to have done another server. So I have one server, two clients. Get these spaced out. And now I need another client in debug mode. I'll connect all of those. Let's now make a client in debug mode. Give this a while to spin up. Okay, we'll let these connect. Finish the connection. Okay, so now we're going to make this atomic. I'm going to execute a move 50 command. I'm going to show that it does not execute locally. We can see that the property change event was called, and because this is an atomic command sent, we're going to send the command to the server with our delimiter and a 1 to indicate that it's an atomic message. So we'll skip over this else that typically would have processed it. So now we come into the, this is still the client, we have to write, and now we come up to the server, which in the selector thread is going to read and then parse that message. So it'll read here in the selector thread. In the worker thread, the broadcast worker will grab that data, we'll split it on our delimiter, we'll parse it and see whether or not we're supposed to return to the sender. And because this was sent with a 1 flag, that means that it is supposed to be atomic. So we'll iterate over the connections that we have and send those back. Okay. Call those writes. Oops. And I appear to have skipped over the read, but I'm just supposed to show you the execution of commands, okay? So, I see, I accidentally earlier stepped into this command, so it did not come back and wait here, which I seem to have just done again. So let me do this one more time. Leave that there. Run the server. Run the writes. Okay. Read in. And now here you can see the client processing the command. Earlier I had accidentally already stepped through this, so it automatically ran through because there was not another breakpoint. But here you can see these have both moved forward the second message, whereas this has not until I step through, and now they've all received the message. So now I have to show that the client can run locally dynamically via the GUI. So I will open up this dialog box to set the local checkmark. Okay, so that's all up to date. So I hit the local checkmark, and now I want to send a command. Say move 50. We'll come here and see that because the client is local, we'll skip over the sending, and we'll just call getSimulation.process command. And now this client has moved 50 forward, while these two have not. So next is pre-written code execution. So I will close out of these threads in debug mode. Start a server. I will start 2 normal clients. And using these commands, I will set the client operate locally, and then I will submit a command to it telling it to move 24. So here we can see our 2 other versions, or 2 other simulations. Now we'll run this new client that is told to submit a command programmatically. Wait for it to boot up. And you can see it moved forward 200 without either of these moving forward. Oops. So now I want to do that in remote mode. Let's make sure I'm closing out the right client. We'll do this remotely, so local will be false. Start this client up. And we can see that all 3 simulations moved forward 200 units. So I'll close all of these, and we'll do the timings. So again, I'll need a server. 2 normal clients running. And here I'm going to iterate over 500 commands, moving forward 1 or backwards 1. 125 units forward, 125 units backwards, and do that twice. That way it all gets contained within the window. Oops. So we'll place these 2 simulations here, and we'll start up a simulation that has those 500 preloaded commands. And I'll keep a record of the timing. So you can see it moves forward, backwards, forward, and backwards. Pretty smoothly because there's nothing else competing for resources really. And we can see that took 4.7 seconds. Comment that out. Close these down. Need another server, 2 clients. And I should mention this, I set the previous simulation to operate locally. Here I will set it to operate over the network, and I will make it not atomic. Again, moving forward and backwards 125 units twice. Put these off to the side. So here we should expect that this client will be a little bit ahead of the others because it can operate the command or process the command before these 2 simulations necessarily do, whether the server just hasn't sent out the messages, haven't read them off their socket. So you can see this process has already started to go back, while these are still reading some queued up commands. And that took a total of 10.5 seconds. And you could see that some messages were missed because due to the scheduling of the processes, a few too many messages from the simulation submitting the commands just got dropped off from the server because some socket buffers were full. So close these out. Again, we'll instantiate a server, 2 clients, and now we'll execute this last bit of code, which sets the client to not be local and to be atomic. This way we should see more synchronous activity. There could still be a little break because one server doesn't, or one simulation doesn't read off the messages exactly simultaneously, but because the client has to wait for a response from the server, it definitely gives the other processes more time. So we should expect these to be more in step. And because of that, take longer. And that's definitely what it looks like. They're all moving forward. Pretty similarly, this process seems to have been gotten priority in scheduling quite as much as the others. So we could definitely use some bigger buffers here, but it's hard to know whether the server or the client is having a full buffer. But this still took over 13 seconds, so significantly longer than the other 2. And that should be everything.